It's me again. How you guys doing? First off, I want to say a couple things about the the last homework assignment that was due. Today is Monday. I'm recording this about 5 o'clock on 5:30 on Monday night. Um, some of your hypothesis tests were outstanding. I looked all the people that did the photographic submission of the homework. They were very good. Some of the conclusions were just spot on. I try to make some comments to pretty much everybody that turned theirs in. Some areas for we're looking at what you should be doing if it wasn't completely correct. I want to um, zoom in on the key here. I've posted this key already, so maybe you've already looked at this, but I want to show a couple things here. First of all, on how the test statistic was arrived at. And I want to make sure that we know how to do this with our calculators. Instead of having to write out the formula like this and do everything like that, we can just put some values in and have the calculator run the test for us. In our test, though, if we are going to go with a calculator driven answer, we must name the test. I've done that in this step. We will run a one-tailed z-test for a population proportion of college athletes that take prescription medication to control pain. I've got that already in my key. Okay. So the idea is that you either write out the formula and show the work, or you name the test and then you highlight the answer for the p-value, you highlight the answer for the z-value as well, and then make um, your conclusions. Okay, so I'm going to quickly go to my calculator and show you the test, and to do it strictly by the calculator. Okay, so what we want to do is we want to go to stat, we want to go to tests, and then a lot of glare there. So now there's not. We want to go down to one proposition z or one proportion z test. Okay, I've got some weird numbers in there. That was something else. Anyway, um, our hypothesized p on this problem, I believe, was 0.47. The number of yeses, the number of students in the sample that said they took pain medication was 30, and the number of people that were in the sample were 72. Now, my proportion will either, for my alternate hypothesis, will either equal the proportion of 0.47, will be less than 0.47, that's this one, less than 0.47, or greater than 0.47. So I've got a hypothesized p, that p sub 0 is either not equal to p sub 0, less than p sub 0, or greater than p sub 0. So it's on this one, we wanted it to be less than 0.47, so that's the one I'm going to hit. Okay? And now we're going to go to calculate. Now we get a z-value of -9 or negative 0.9067, a p-value of 0.1822. Of course, it gives you the p-hat value of 0.4166, and it tells you that your sample size is 72. Okay, so remember those data values right there. Let's go back to our problem and see if those were close. So our z-value is negative 9.062, p-value is 0.8114, yeah, and the p-hat value is 4.167. So it does all of the numbers for us if we know what we're looking for. And I think some people use this as a check to make sure they've done it right. And if you want to do it that way, then that's good too. Okay. So anyway, that's how you do the test with the calculator. That's how you get the numbers with the calculator. Okay. Let's go back. And get on the document camera again. Now what we're doing is the last part of 9.2. I'm not going to make it a full hypothesis test. We're not going to be doing everything. But I want to show you what's different about a two-sided single population proportion test. Okay. This is two-sided. It's not a greater than or less than claim. It's a does not equal claim, or it differs from. So you have a copy of this. Hopefully you have printed it out for notes so you can take notes on it. If not, you just take notes on your own paper. But anyway, according to the National Institute for Occupational Safety and Health, job stress poses a major threat to health of workers. A news report claims that 75% of the restaurant workers feel that stress has a negative impact on their personal lives. Managers at a large restaurant chain wonder whether this claim is valid for their employees. A random sample of 100 employees finds 68 answer yes when asked, does work stress have a negative impact on your life? Does this data provide convincing evidence at the alpha equals 0.10 or 10% level that the proportion of all employees in the chain who would say yes differs from 0.75? Okay, so null hypothesis. We're still dealing with proportion, so the only thing we've ever done is this. So that report claims it's 0.75. Our alternate hypothesis does not say that it's less than or greater than the 0.75. That's not the claim. All it says is that it doesn't equal 0.75. So our null hypothesis was equals, and our alternative hypothesis is it doesn't equal. This sets us up for a two-sided test. Just real quickly, if the actual P proportion is 0.75, and we're thinking that it could differ from that, then we could have a sample statistic that ends up way over here. So the sample statistic would be way less than, or we could end up with a sample statistic that ends up way over here that it's way more than 0.75. We don't know. We haven't run the sample statistic yet, but that's why we're talking about a two-sided test, because in either case, if it's less than or greater than, it will give evidence that P doesn't equal 0.75. Not that it's on one side or the other, but it just doesn't equal. Okay. So P is basically the true population proportion that would say yes to the question. Now, don't say in your conclusion that it's the true population that said yes. Say it that would say yes. Because the population is never going to really be asked this question. The sample got asked the question. Okay? So if you say this, the population that said yes, well, then you're referring to the sample. You want to be referring to the population. The population never is going to get asked this question. And so when we generalize on this, it's a hypothetical that what would they say? They would say yes or say no. Well, if we generalize, it would be the population that would say yes. A little technical thing there, but something that I kind of came across recently and needed to pass that on to you. Okay. So the conditions, like I said, I'm not going to go through the whole thing. Conditions are random, independence, and normality always. Okay. Looks like it was a random sample. The independence is the 10% condition. Random sample of 100 employees. This is a large chain. I would assume that they'd have way more than this. Okay. But the population we're talking about is is the population of this chain's restaurants. Not all restaurant workers in total, but this chain's restaurant, okay, or this restaurant chain's employees. So it's a large restaurant chain. We are going to think that 10 times the sample size of 100, okay, would be less than the population of this chain's workers. So we're going to say it's a large restaurant chain and they have more than 1,000 workers. Okay, we'll make that assumption. Remember to really hone in on what population you want to generalize to and make sure the conditions fit that population. Normality, sample size times the proportion has got to be greater than 10. Sample size is 100, proportion is 0.75, so that's 75. And then n times 1 minus p, it's got to be greater than 10 as well. 100 times 0.25, okay, is 25, and that 25 is greater than 10 as well. Okay. All right. So all the conditions are met. We can keep moving. The test statistic, can do this by hand, then we'll check it with the calculator. Okay. Z is p hat minus our hypothesized proportion, and then square root of hypothesized p, 1 minus hypothesized p over n. I've written that so often recently that I think I've got it memorized, and you should as well. You should be able to pick that off of your test sheet as well, the sheet that you're going to get from the AP test. But it is exactly what we need it to be. And just showing how we get this. Remember, this is a z-test statistic. Standardized test statistic is your statistic minus your parameter over your standard error. So that is, the statistic was p hat. Parameter we're hypothesizing is p sub 0. So p hat minus p sub 0. And then the standard error of the statistic, that's the standard deviation. Okay? So on the second page, it shows us the standard deviations. The random variable, parameters of sampling distribution, standard error. Okay? So for one population, standard error, the sample size is p hat, but of the sampling distribution, that's p. So p times 1 minus p over n. This is what we use for the confidence interval because we don't have the hypothesized p. We don't have what it is. We don't know what it is. We're trying to figure out its limits left and right. We do have a hypothesized p for our test, and so this is what we use for the denominator of our formula. Okay. Of course, that's the standard deviation of our our sampling distribution. Okay. So here we are. Oh, I never did p hat. That's silly. P hat, of course, is going to be 68 out of 100. It says clearly 68 out of the 100. So this one's going to be 0.68 minus 0.75. And then the square root of 0.75 times 0.25 divided by their sample size of 100. So we get negative 0.07. All right, that should tell us something. Our z for our sample is going to end up in this tail. Figure out what the standard deviation is. 0.75 times 0.25 divided by 100, and then raised to the 25 power. Standard deviation is like 0.043-ish. Okay? So I think we get 1.61, which is basically 1.62 negative. So our z-score is going to be 1.62 negative, and that's down here. More than one standard deviation, less than two standard deviations away. Okay? Now here's where the difference in the two-sided versus one-sided. Everything we've done so far has been exactly the same, but we have to figure out how likely this is to be less than that or greater than that. So when we get this p-value for just the lower tail, negative 1.62, we get 0.0526. So having a statistic that is this, the statistic of I lost my 0.68. Having a 0.68 proportion, if the true population proportion is 0.75, getting 0.68 will happen about something as low as 0.68 will happen about 0.0526 probability. And if we went with our alpha value of 0.10, right now that alpha value is greater than our p-value. So we would reject the null hypothesis. However, that's just the p-value for the lower tail. This is 0.0526 right here. But this was not equal to 0.75. So there's going to be an equal and opposite in the other tail. The upper tail is also 0.0526. And so the total p-value is 2 times one of the tails. So now we're looking at 0.1046 for our p-value. Now this is greater than our alpha value, which equals 0.10. We've got a p-value that's greater than our alpha value. So now our decision is fail to reject. We do not find convincing evidence now the proportion of all employees in this chain that would say yes differs from 0.75. So then, of course, you have your conclusion. Now, this is very similar if you look at it. It's very similar to doing a confidence interval. This inside, if we looked at just our alpha value, we could have a 90% confidence interval and 5% on each tail. This 5%, remember, is our alpha value, but now we have an alpha value in both tails, so that would give us the alpha equals 10%. Okay? So if we went and did a confidence interval, that might tell us a little bit more about the problem. It might tell us the lowest number where on one side we would reject the null hypothesis, and on the other side we would fail to reject the null hypothesis. It would tell us that number there, and it would also tell us this upper number where we, again, on this side fail to reject, and on this side reject. Okay? So read up in the book about how the confidence interval, how it's connected. Go through that problem in the book. It talks about this, according to the Centers of Disease Control and Prevention, the CDC website, 68% of high school students have never smoked a cigarette. Do that problem on page 577 and work it all the way through and see the confidence interval. So, in other words, finish up the chapter or finish up the section of the chapter. And you'll be very good to go. Okay, read that whole thing, just about 2 pages. Go through the problem as well. Okay. All right. We'll just make sure we understand the calculator portion of this. We are now going to do that test on the calculator. I'll zoom in a little bit and I'll show you how the calculator kind of already does the information for us. So stat, test, it's still a 1 proportion z-test. Our new test statistic is now 0.68. Excuse me, sorry. I'm bad there. Our hypothesized, sorry, that was supposed to be our hypothesized proportion is 0.75. The 6.8 comes from the numbers that would say yes in the sample and the sample size. The last thing we got to do is, was the alternate hypothesis, was it not equal to the 0.75, less than 0.75, or greater than 0.75? That's going to be not equal to 0.75. So we hit that calculate, and let's see what we get. A z of negative 1.61, I'm going to zoom out a little bit. A z of negative 1.616, which is negative 1.62, so that's good. Now, it gave us a p-value not of each tail, but of the combined p-value. 0.1059, we got 0.1046. So we were close, and the calculator is close enough. It's definitely above the alpha value of 10, of 0.10. Okay? All right. So understand when you get the p-value here on the calculator, you don't have to double it because it's already done it. Okay? It's already done the p-value for you. You just got to make sure that you put 1 propagation z-test and not equal, not the less than, not the greater than. Okay? Hope that clears some things up. We are now finished with 9.2. I will be assigning all the homework for 9.2. If I haven't done so already, I will have to look and see if I've done that already. But anyway, we can do that. And then we'll start looking at the alternate examples. Make sure that we have a full understanding before we try to go on and go to different types of tests. Okay? Again, we are going way slow through this. I want you to make sure that you understand how to do this first simple hypothesis test like nobody's business. I want you to make sure you're doing the right conclusions. So we are going painfully slow through this. And even because of the distance learning, we're going even more painfully through this. We will get to where we need to go. Okay. And then the last thing, I know you're not going to like this, but your review starts next week. Even though we're on spring break, the videos through AP are starting next week. My highest suggestion, since you got nothing else to do, go through and watch the videos on time. I think they are exceptional. I think it'll clear up lots of stuff that you heard the first time from me. I think both instructors are excellent. Please, please, please go through all of the material on the videos, and the review videos start next Monday. The rest of this week is finishing up the course. Next week starts the review. So, yeah, I would suggest that you go through all of that review stuff. Okay. Till next time. Thanks, guys.